The next problem that we will be solving is pangrams. So let's get to know what pangram is. A pangram is a string that contains every letter of the alphabet at least once. A famous example of a pangram is "The quick brown fox jumps over the lazy dog." Here our task would be write a program that takes a string, determine whether it's a pangram. So here the input and output is given. Input will be a string. The length will be between 0 to 200 inclusive, and the output will be either pangram or not a pangram based on the input. So let's discuss how we will do, and then we will solve the problem using Python. To solve this problem, we will use hash table. So let's say our input is string. It is the brown fox jumps over the lazy dog, maybe. We will name this hash table as checker. What it will do, it will make an entry for all the letters in the string, and definitely we'll have to convert the whole input string into lowercase so that it will be easier for us to convert. So maybe this is a lowercase. So for each letter present in the string, I'll make an entry here that, okay, for the first letter T, it's present and it's part of the alphabet. I'll make an entry as. For the second one, H, I'll make an entry in the hash table as true. And that will be continued until the last element. But yes, this is something that we should be careful. There can be spaces, there can be comma, and other punctuation marks, and some special characters as well. But here our main interest would be with the English letters. So for that, I will define another set, which is alphabet. It will contain all the letters of English alphabet, the 26 letters. So whichever element I find in string, I will compare it and I will check whether that element is a part of this alphabet set. If it does, then I'll make an entry to the dictionary or the hash table. And finally, after we're done iterating over the string, we should say that the length of this card checker has to be 26 for this string to be a pangram. If the length is 26, then we can say this string is pangram. Otherwise, we will say no. If it's not 26, it's not a pangram. So that would be the process of the solution. Now let's jump to the code. Now let's solve the problem using Python. And we're going to follow the same structure. We're going to take the input in the main function, then we will call another function where the result will be determined and will be returned to the main function. So let's call the input as input string. We're going to take the input. We're going to remove all the white spaces on the left and the right, and then we'll convert the whole string into lower, because we can just consider the lowercase characters to decide. Now we will solve the problem, and we are going to follow the same structure as before, that in the main function we will take the input and we will define another function where the actual result will be determined, and we will print the result from the main function. So let's take the input first, string. We're taking the input, getting rid of the spaces on the left and right, and we're converting the whole string into lowercase. Then we're going to define another variable which is result. I'm going to call right. So I'm going to define the function as is pangram. It's going to take s string and will be returning, let's say pass for the time being. Is pangram, it is going to send input string. Right. Now we will do the main thing here. So as discussed, we will create a set where all the letters of English alphabet will be kept in lowercase. So this is the set Now we will use the ASCII value of A, which we will find by using this function ORD. Now what we will do, we'll say for I in range 26, for obvious reasons. There are 26 letters in English alphabet. We are going to add each alphabet after converting ASCII value. So this char function will convert this value into the corresponding character. Now we will define another variable, which is car tracker. It will keep track of whether the letter is present in the string or not. Okay. Now what we will do? We will say for each character, we will iterate over the string. If the character is an alphabet, we will say true. We will mark that character in this hash table as true. Right. And that's how we will iterate over the whole string until the end. So this if condition is really crucial, because in the string there can be special characters, there can be spaces, but we will ignore them and we will consider all those characters that are in this alphabet, which means the 26 letters. Okay. Now we have this car tracker where all the characters that are present in this S are tracked. So for this string to be a pangram, there should be 26 letters in this tracker. Otherwise, it will not be a pangram. So how can we check that? If len tracker 6, we will return pangram. Else, we will return not a pangram. Now let's run the code. And I'm going to input here. Let's press enter. It's showing nothing. It's because I'm taking this result, but I'm not printing it. So this is really important. I'm going to print the result. Now if I run it, and if I want to paste the code, it's going to say pangram. Now let's run it again. I'm pasting the result, but I'm going to get rid of some letters. Now if I press enter, it says not a pangram. So our code works for the test case. Now we will submit the code in the website to see whether it runs for all the test cases. But before that, there is another thing. So in this last 4 line, if this condition is true, it will return pangram, then definitely it will not go into this condition. So we can simplify this code and we can say that we can get rid of this else and we can write something like that. It will simplify the code, and if we run the same code, we'll see it will give us the same output. So this is another way you can improve the readability, but that solely depends on how good you understand the sequence code execution. We are here and we are going to submit the code. Now we can see that our code is accepted for all the test cases. So it's successful. So much. And now we are going to go to the next problem.